Okay, so picture this. You're typing a prompt into ChatGPT, maybe asking it to write an email for you, or you're creating some amazing image with another AI tool. It feels like magic, right? It's instant, it's digital, it seems totally weightless. But what you don't see is that behind the screen, there's this massive physical process kicking into gear, one that's drinking up a truly shocking amount of one of our most vital resources, water. So today, we're going to pull back the curtain on the hidden environmental cost of AI. So what is the real environmental price tag for that single answer, that one image, or that little snippet of code? It's a question we almost never think to ask, but believe me, the answer has some pretty staggering implications for our planet. And this chart right here, wow, it really puts the scale of the problem into perspective. We are looking at a potential 11-fold increase in water consumption from just 2024 levels, peaking around 2027. Think about that. This kind of surge can put incredible strain on local water supplies, especially in those sunny, dry regions where, ironically, a lot of these data centers are built. This isn't some slow leak we're talking about. It's a tidal wave of demand. To give you a more concrete idea, let's talk about training these models. Just one training run for something like GPT-3 can guzzle down 700,000 liters of water. For comparison, that's enough water to manufacture 320 Tesla Model Ys. And remember, that's just the direct on-site cooling water for one model, one time. Now, let's zoom out from a single training run to the whole global picture. The numbers just get wild. Projections show that by 2028, AI's annual water use could hit 1.07 trillion liters. That is more than the entire global bottled water industry uses in a year. It's just a mind-boggling amount of water. Okay, so where is all this water actually going? It's really easy to just imagine giant server racks getting hot and needing to be cooled down. But the real story is, well, it's a lot more interesting than that. Let's follow the water trail and find the real culprit. The common assumption, right, is that it's all about cooling. You've got these massive data centers, these warehouses full of computers running 24/7. They must get incredibly hot, so you're just pumping endless gallons of water through them to keep everything from melting down. But is that the whole story? No, not even close. And here it is. This is the big reveal. The vast majority of AI's water footprint, a whopping 75%, it's not from cooling the servers directly. It's from generating the absolutely colossal amount of electricity needed to power the whole operation in the first place. Let's break this down real quick. You'll hear experts talk about 3 scopes of water use. Scope 1, that's the direct cooling we all think about. Turns out it's only about 5 to 10% of the total water use. Then there's Scope 3, which is the water used to actually manufacture the computer chips. That's another 10 to 20%. But the real elephant in the room, the big one, is Scope 2, the water used by power plants to generate all that electricity for AI. That's the game changer. And get this specific model you're using can make a world of difference. To generate, say, a simple 10-page report, GPT-4 might use around 60 liters of water. But a smaller, more efficient model like Llama 3, it uses less than 1 liter. This just goes to show you that the software choices we make have a very real, very direct physical impact on the world. Okay, so the problem is clearly huge, but it's not hopeless. There's actually a race happening right now to make AI sustainable, and some of the solutions are genuinely fascinating. So let's see what the industry is doing to turn off the tap. Now, the most impactful solution might not be what you think. It's not about some fancy new hardware. The single biggest efficiency gain comes from using smaller, more specialized models that are trained for specific tasks. We're talking about a potential 500% improvement in efficiency that absolutely dwarfs other fixes. So the path forward isn't just about building more efficient data centers or cooling systems. It really points to a fundamental shift in strategy. The future of sustainable AI seems to be all about being smarter and more focused, not just bigger and more powerful. And beyond just using smaller models, there are other powerful tools in the toolbox. For one, switching to renewables like wind and solar can slash that huge Scope 2 water footprint by up to half. Companies are also rolling out advanced cooling tech, like liquid immersion and really sophisticated water recycling systems. And here's my favorite part. In a kind of beautiful circular twist, they're using AI to make their own AI infrastructure more efficient. Google's DeepMind famously used this trick to cut its data center energy use by 40%. All of this brings us to the big, ultimate question. Are we looking at an existential crisis for artificial intelligence, something that could stop it in its tracks? Or is this just a necessary and hopefully manageable transition? So let's just ask it plainly. With these massive environmental costs piling up, could this be the beginning of the end for AI? Is the entire project just fundamentally unsustainable? And you know what? The answer we get from the experts, the researchers, the people deep in this field is a pretty clear and resounding no. AI is not going anywhere, but it is being forced to grow up and to change fast. And why are they so sure? Well, it comes down to 3 key reasons. First, the economic gravity is just immense. We're talking a projected addition of nearly $16 trillion to the global economy. Second, AI itself is an incredibly powerful tool for finding climate solutions, potentially helping us cut emissions by 3 times more than its own footprint. And third, the industry momentum is just unstoppable at this point. Billions are already being poured into creating a more sustainable AI future. So if the technology to fix this exists, what's the real danger here? The real threat is what you could call a failure of governance. It's the risk that companies and governments simply fail to implement, to measure, and to enforce the sustainable practices that we already know work. The tools are there. The problem is the will to use them. And this number tells the whole story of that governance gap. Right now, as we speak, only about 2% of firms that are using AI actually have adequate responsible AI measures in place. 2%. That is the massive disconnect that has to be fixed. Which really leaves us with this final, crucial thought. It seems like the era of just unaccountable, unchecked AI expansion is coming to an end. The technology itself is going to keep evolving, of course. But the real question that all of us have to answer, as developers, as policymakers, and even as users, is how do we make sure it evolves sustainably? The future isn't written yet,